Welcome, everyone. I'm Rob Sullivan. I'm on the committee for the Electronics and Computing Division of Engineers Ireland, and I also work for Bank of Ireland. So I have the pleasure of welcoming my colleagues here to take us through customer analytics and how these guys drive insights to impact. And I'd like to introduce you to our speakers. Needy, she's our commercial analytics manager. She's over a decade of experience working in the private equity, tech, and consumer sector, and she helps stakeholders understand what's happened and the story our customer data is trying to tell us. Scott, he's a senior data scientist with a PhD in physics. He's experienced in building production-grade machine learning systems, and Scott helps stakeholders predict what could happen and identify which customers to target. Alex, she's our decision practice lead in the bank. She oversees all operations and large-scale transformation projects. She's over 2 decades of experience in research and data analysis, and Alex is an expert in our automation tool, PEGA, and helps stakeholders deliver that right message to the right customer at the right time. And finally, I get to Aaron Gibney, who's our senior manager in performance analytics and measurement. He's a background and expertise in econometrics and causal inference. Aaron helps stakeholders understand what worked and future opportunities then that they can pursue. And together, these speakers are going to give you a quick overview of that chain from customer insights to data science to that PEG automation, and then that performance measurement at the end, and then give you then what they project what the advancements that may happen in their respective fields. To just give you a bit of a flavor and to ground us in where we are. In Bank of Ireland, we opened our doors in 1783, but we're over 2 centuries old. We've expanded through we've grown through expansion, innovation, transformation, and it started with our branch networks that we expanded around the country, and now we're in the likes of the UK, and that was to meet the demand of the customer at that point. That old school relationship you had with your bank manager. Bank manager approach, but we had the first ATM, we had debit cards, we launched our website, mobile app, and now we facilitate more self-service banking. But the customer and the customer's journey has always been at the heart of what we're doing, and this long history of adaptation to customers' needs and marketing trends brings us then to this next chapter. And so now we're at the point where we're trying to deliver those deeper insights and that more personalized experience. And that's what these guys here today want to talk to you about. So I'll hand it over to Needy.
Thanks, Rob. Hi, everyone. Good afternoon. My name is Nidhi Badnani, and I work as Commercial Analytics Manager within Commercial Insights team at Bank of Ireland. Today, I will be walking you through how we generate customer insights, specifically focusing on Commercial Insights team and how those insights flow across broader customer analytics team, and ultimately how they drive commercial and customer-centric value for the bank. So, just to set the context, at Bank of Ireland, our customer analytics team plays a vital role in ensuring that every decision we make is grounded in data, evidence, and a deep understanding of customer behavior. So, our customer analytics team has 4 core teams: commercial insights, data science, decisioning, and performance analytics and measurement. Each of these teams has their own strength, but it is the way we connect and collaborate that creates a powerful and end to end analytics ecosystem. And that's what I will talk about today. So, where it all starts. It starts with business and marketing teams coming to us with a question or a challenge. They may ask questions such as: what's happening in the market? How are our customer needs changing? What are the biggest risks or opportunities in the market? In other words, they bring us the problem, and our role within commercial insights team is to turn those problems into clarity. So what commercial insights team does now? This brings me to the heart of the slide, the role of commercial insights team. Our job is to convert data into actionable insights and identify opportunities for the bank. We sit at the center of the analytics flow, acting as a bridge between the business stakeholders and the more technical analytics teams. We do this by understanding the customer. We start with the customer behavior and needs, how they act, how they shop, how they borrow, how they respond to the rate changes, and what moments matter most to them. Then we connect different data sources. We analyze internal customer data and align it with the competitive market and external macroeconomic trends. We convert insights into visuals and stories. We create insights pack, dashboards, and narratives that clearly explain what is changing in the environment and what that means for the customers and to the bank. We spot opportunities across the customer journey, whether it's acquisition, cross sell, retention, customer experience, and we highlight where bank can take meaningful action. And the most important one is we ensure data privacy. As we work with the sensitive customer data, privacy and responsible data use are built into every stage of our analysis. So everything we do is fully aligned with GDPR and internal governance to ensure customer privacy is protected. And most importantly, we share those insights with the teams to act on, whether it is business or marketing teams who devise strategies bases our insights and potential opportunities that we identify. Or it is data science or decisioning team who further work on the data and insights that we generate. So let me just illustrate this with the help of real life example from home buying squad that look into mortgage segment of the bank. The business wanted, for example, if the business wanted to understand how the mortgage customer landscape has changed in past 1 year. So over here, commercial insights team analyzed the internal customer data, aligned it to the external market data from CSO website, Banking and Payment Federation of Ireland website to tell what's happening in the Irish market and how the mortgage landscape is changing. And we further added broader macroeconomic indicators like disposable income, affordability factors, and so on. From this, we identified a few of the key insights and the key shifts in the market, like the share of first-time buyers was rising, net disposable income for many customers has improved, average sanctioned amount has gone up, and there is certain change in the geographic shift where the customers are taking more mortgages. We also identified a risk that customers approaching the end of their fixed rate period were significantly more likely to shop around, increasing the chance of attrition. That finding became an opportunity, and we handed this opportunity to data science team. Once we identify this opportunity, data science team then turned those insights into predictive models. In this case, they developed retention model using indicators such as customers remaining fixed rate term, balance and repayment behavior, tenure, product type, and any risk that signals customer profile. These models predict which customers may be likely to leave the bank when their fixed rate ends. And this model then feeds directly into the decisioning team. The decisioning team then takes the predictive models and bring it into the more real-time customer engagement platform. They create targeted journey for both inbound and outbound communication. For example, customers who are 1 year away from rolling off their fixed rate receive proactive retention messaging, either on their app, via email, or when they call the bank. This is where the insight is directly turned into direct customer action. Now, how measurement team completes the loop. Finally, our measurement team then evaluates what impact the campaign had, how many customers were retained, how much commercial value was generated as a result. They also identified opportunities to optimize future campaigns. And post this, commercial insights team further analyzes if the campaign actually worked or not by further analyzing the customer data. This brings the insight cycle full circle. Now, why this actually matters? Each of the teams within commercial insights team contributes to a bigger goal, creating value both for the customer and the bank. Some of the core outcomes include improved customer journeys, clear measurement of commercial value, better targeting, segmentation, and communication, more informed decision making, and earlier detection of customer needs and intent. Ultimately, each team enhances the output for our customers and help drive commercial outcome for the bank. So, just to summarize, the strength of the customer analytics at Bank of Ireland lies not just in data, model or technology, but how the teams work together. And commercial insights team connects business need to analytics solution. That's all from the commercial insights perspective. I will now hand over to my colleague Scott from the data science team, who will double click on the role of data science and how they create propensity models. Thank you.
Thanks very much, Nidhi, for that great introduction. And thank you for having us, everybody. So as Rob mentioned, I'm Scott. I'm a senior data scientist, and I'm going to give you a bit of a whistle-stop tour of how the data science team in customer analytics functions. So as Nidhi mentioned, we partner with commercial insights, the contact strategy team, and the measurement teams to help ensure that we are making the best decisions for our customers. And us in the data science team, we do that through a number of different methods, usually involving machine learning and other data best practices. So how we do that is we have a few main areas of focus. So the main one, our main area of focus would be building propensity models. So these are models that predict the likelihood of customers churning out, converting their product into maybe an upgraded version, their likelihood of response given a certain messaging. I'll talk a bit more on those later on in the presentation. We also do forecasting models. So maybe we want to evaluate how many customers we think are going to take a mortgage with us in the next year. And then we can adjust our strategies based on that forecasted demand. A very important aspect of our job is monitoring our models when they're in our production space to ensure that they are being consistent and that the outputs are what we expect them to be. But none of these work without robust data pipelines being in place. So we want to make sure that all our data feeds are consistent, all our data transformations are correct. When we get into production, our models are running in a timely manner, and then the results are being sent through to the contact team when they need them. So our key focus areas are making sure we're targeting the right customers at the right time, making sure that we properly assess the risk and the impact that any model we deploy might have, both on our customers and ourselves as a bank. We have to ensure that our models maintain their health and their reliability. We also, as part of our team role, try to scope out ways to improve efficiencies throughout the wider organization and improve the data usage in the organization. And the final thing that we've been moving more into in recent times is exploring new and novel like model algorithms and technologies to help improve what we can provide to our team, to our customers, and to the wider bank. So next slide, please, Rob. So this slide is an overview of what a propensity model is. So it's the probability of a customer taking a specific action, and that is built using historical data about the actions customers take, whether that's buying a product, leaving the bank, something of that nature. So the probability scores are output a score between 0 and 1, where 0 means they're very unlikely to take a certain action, and 1 means they're very likely to take that action. So the reason these are important to us is they allow us to categorize and decide who we want to contact. So we may only want to contact the top 10% of customers in terms of their probability score. But one thing that we have to make sure of is that we build models across a lot of different spaces. So we have to calibrate them against each other to ensure that when it comes to contact strategy time, that we're not just spamming with a particular message for one product because those probabilities are the highest. So a bit of an example on the right-hand side is we have this heat map that goes from 0 to 1 in the probabilities, and all the black dots are customers, basically. So if in this churn example at the top, we might want to have a phone call with the top 10% of customers who are likely to close their account, because we've found historically that maybe phone calls are best in this scenario. Then the next 20% of customers, we'll maybe email them, like a lighter touch approach, just to get them thinking about our product and potentially staying with us. Then maybe if we have another problem where we're looking at the likelihood of a customer upgrading to a different account, we'll maybe email the top 20%, and then the next 40% we'll want to send them a nudge in the app, again, just to put it in their mind and hopefully get a conversion out of that. Next slide, please, Rob. So when it comes to building propensity models, you can take a number of different approaches, and there's a number of different algorithms you use. So I'm just going to walk through one of the algorithms that we would frequently use for that. And this is a random forest. But before I explain what a random forest is, I have to explain what a decision tree is. So a decision tree is essentially a flow chart of if-then rules. You have these nodes, and at each node, a yes/no question is asked to help you classify the final outcome. So this figure is just a simple example of that. We ask an initial question: have they had more than 3 calls in a month? If the answer is no, they're low risk. If the answer is yes, we move on to the next question. And then we further differentiate between medium and high risk and potentially other questions. So decision trees are good in the sense that they're very explainable, they're easy to interpret, but they can be a bit unstable, and they generally don't work well on data that has not yet been seen by the initial model. So an approach we like to take is to use a random forest instead. So random forests are a collection of decision trees, and that the amount of decision trees you use to create your random forest is a parameter that you can tune in your initial setup when you're building a model. So each of the trees in this forest will independently come up with its own score on a given outcome. And then what happens is those scores are combined together to create an average. Well, at least in our case, it's used to create an average, and then that gives us a final score. So each tree in this forest receives a random subset of the initial data and of the initial features that exist within the data. So this means that we don't get bogged down in stuff like overfitting. We have well, it's not a collective agreement, but it's an average agreement across a number of different spaces. And this overall leads to better outcomes for us. Yeah, thanks, Rob. So this is just a simple worked example of how a random forest might work. So here we have a customer profile. They've got 4 products. They've had this particular product for 6 months. They've made 2 calls, £100 €100 a month, in average spend, and they last logged into the app 3 days ago. So tree 1 is looking at, have they called less than 3 times? Yes. Do they have more than 2 products? Yes. Okay, we think that means they're low risk at churning. Tree 2 looks at something slightly different. Did they last log in less than 2 weeks ago? Yes. Has their average spend been less than €200? Yes. But so it makes an assessment that they're high risk. And once you combine the outcome assessments from all those trees, we end up with a final score of a medium risk for this particular customer. And on the right-hand side, we can see how each particular feature that we input into this forest impacts on the final churn score. So the total products, they had 4. That generally means they're quite a stable customer, so they're maybe less likely to churn out. But they've not had the product for very long, so maybe they're more likely to churn based on that, based on historical trends that we've seen. So yeah, random forests are good. They allow us to get a better sense, or they allow us to like really interpret what's going on in our underlying data and why certain decisions have been made in our outcomes. Next slide, please, Rob. So something I mentioned at the start, but it's quite often overlooked when it comes to building machine learning models, is actually monitoring those models when they're running. So these models degrade over time, and that can be due to a number of different reasons. You get seasonality, you get macroeconomic factors shifting, or you just get a change in your customer base. So we have to monitor that, and it's important that we have like guardrails in place for that. So an example of one metric that we might look at is something called population stability index. So it tracks score distributions, whether that's model outputs or data inputs, against baselines, and we continually check that over time. And we will have thresholds in place where if that metric exceeds a threshold, we will stop producing new outputs for that model, stop sending them to contact teams. And from my background in physics, I know everyone liked an equation in a presentation, so I assumed engineers would be the same. But basically, you get your two different score distributions, your actual and your expected, which is your baseline. You bin them and you assess the difference in each bin to get your PSI score. And then, yeah, we examine that against our thresholds. Next slide, please, Rob. And yeah, just a final wrap-up slide. So we take our raw data, whether that's call logs, product, like coverage, customer history, etc. We put that through all our data engineering pipelines to ensure that we're getting clean, consistent data. That then feeds into our machine learning models, which we then monitor and track over time. And once our model outputs pass our monitoring, we feed them on to the contact strategy team. So this allows us to create a more tailored customer experience and produce a measurable impact on retention and conversion. And with that, I'll pass on to Alex now to talk more about how they actually use these outputs.
Ryan, thank you, Scott. Hi, everyone, I'm Alex. Apologize for my voice. I'm fighting a bit of a cold, but I'm Alex. I run the decisioning team in Bank of Ireland, and I'm just going to give you a bit of context for what decisioning does. So far you have heard how commercial insights is producing insights for the business to kind of decide what is the roadmap, what is the direction they need to take. And then you have the data science that produces models that show us where the customers are in different contexts, like are they ready to churn for different products, or are they ready to maybe get a new product? So what do we do with this information? And what are the actions that we need to take so that we can serve our customers best or meet any challenges they might have? But also, what are the messages we need to send our customers so we can meet our own business objectives as well? And here we need to meet a healthy balance between what the customer needs and what are our own business needs. And for this, we use PEGA Customer Decision Hub. This is a decision and solution offered by PEGA Systems. Just to put it a little bit in context, traditional mass marketing or mass communication techniques that use segments and batches are outdated now and unsustainable in the current market context where everything changes very fast and people want now to be served in a personalized way and not put everybody in the same bucket. So the PEGA Customer Decision Hub approach these interactions is through one-to-one customer engagement, or in our case, is Customer Decision Hub. Through this tool, companies, and we can transition our communication away from the one-to-many campaign-driven approach to the one-to-one real-time approach. And we And what this allows us is to have a consistent, contextual, and relevant conversation with the individual rather than with a pool of people. And this happens across many channels, and it uses also many systems within the bank. So in other words, we have one piece of intelligence that acts as a single decision of authority across the application ecosystem of the bank. So in PEGA Customer Decision Hub, this centralized brain is the core feature that uses AI as well to enable this one-to-one customer engagement that we all want. Can we move to the next slide, please, Rob? Thank you. So the brain collects data from every customer engagement across the enterprise. It collects data from the predictive analytics that data science guys produce. It uses adaptive analytics and text analytics. It uses data about the customer, all kinds of inputs from across the organization. Most importantly, data about the customer, and it outputs what we call next best actions, and these are the actions that we end up putting in front of our customers. So it combines analytics, business rules, customer data, data collected from each interaction to create these actionable insights that it puts then in front of the customer on different channels. So all of this happens in milliseconds, and before interacting with the customer in these 500 milliseconds, in our case, it combines thousands of, or hundreds now in our case, business rules and predictive and adaptive models to determine what are the customer needs, what are the interests to ensure the next best action is relevant, but also what are the business needs as well. So it maintains that balance when analyzing customer by customer. So how does it do that? So can we go to the next slide, please? Thank you. So let's consider our customer. Scott, you talked before me, so I'm picking you. With the centralized brain, instead of looking at one single action and then including Scott in that pool of people that would get that action, whether it's an email or an ad in the app, PEGA starts by all the potential actions such as service, retention, nurture, everything that you can do for that customer now. But although AI drives the next best action, it doesn't do it on its own. So marketeers still have a control, and they are the ones that establish the criteria that AI must meet to consider beginning these communications by setting up the engagement policies. If we go to the next slide, that is a bit expanded there. So, for example, you establish eligibility and you say that a particular action cannot go to customers that are under 18. Or you can set the applicability rules to define if the action is appropriate at the given time. So, for example, if Scott already owns a competing model, or he's in a churn risk model, predictive model, then maybe some of the offering him a new product would not be applicable in this case. Maybe a retention action would be better for Scott. And then you have suitability as well, and suitability determines whether an action is in the best interest of a customer. So if they, for example, have a high probability of default, we don't want to offer a customer something that might make them end up in collections because they don't have enough funds for the monthly payments. So if a customer fails to meet all these conditions, then the AI does not consider that action as well. So once the system has narrowed this funnel from many actions to a few actions, then the AI takes over and it determines how likely each action is desirable to the customer. Can we go to the next slide, please, Rob? Thank you. So um, um, it determines this propensity score. This propensity score is created by our adaptive models, and this is the likelihood of a customer to engage with that particular action. Next, it determines the value each option generates. Next, it determines the context weighting. So we can set up some context for our customers, whether we know that they have been complaining before. Those customers can have a complaining context that has a high value that is applied then to some of the actions. And we can, by setting up this context, we can push a little bit actions that are a bit more empathetic to that particular customer. And then it uses the business value, determines for each options what is the value that is going to generate for the business, what is the impact if the customer reads the content or accepts an offer, and then we also have the possibility to put business levers on these actions. And remember that at the beginning I was telling you about this balance that we need to maintain between what the customer wants and what the business needs as well. So customer versus business needs. And these are propensity and context are all about the customer. Business value and business levers are all about the business. The priority of these actions is a product of all of these: propensity multiplied by context, by business value, and by business levers. And this is how the AI decides what is the highest priority or the next best action that Scott needs to see. And in this case, I think it is the 523 is the standard credit card, for example. So in summary, Customer Decision Hub is an always-on brain that acts as a single centralized decision authority. It uses data about the customer, including past interactions, including the predictive models as input. It uses then advanced AI techniques to make predictions. And obviously, the decision strategies deliver consistent and personalized next best action across multiple channels. And in our organization, those channels are mobile, email, SMS, push notifications, CRM, direct mail. And the next slide is basically an example of the materialization of all of this, of what I've explained to you. So this is our mobile app. When a customer logs in, this is what they would see on the home page. And the circled ads on the app are decided by PEGA. They're decided in milliseconds. And for this particular customer, probably they would have been, we would have had 50 to 100 actions that would be eligible for this customer, but AI decided to put a certain one in the hero and 3 next best actions on the tile. And that's about it. That's what PEGA does. Thank you very much. I'm going to pass this on to Aaron now. Thank you.
Thank you, Alex. Okay, Performance Analytics and Measurement Team, also commonly known as PAM. So PAM, in essence, is the team that measures everything that's coming through the customer analytics team. We measure things like incremental sales and give return on investment insights back to our stakeholders. And we try to convert all of our measurement insights into scale, cap, or stop actions. And this closes the loop on the analytics chain that Nidhi introduced at the start. So I'm going to walk through a little bit about what the PAM team is, what we do, where we sit within the analytics chain, and walk through 2 case studies of real measurement in action at Bank of Ireland. So We kind of do two main things. We maintain and create a range of dashboards. So these, you can think of these as a dashboard on a car. They give a kind of indication of performance, a kind of descriptive indication across a range of KPIs, a whole range of data that we try to capture into these dashboards that give us at least the kind of first descriptive layer of performance. The next element of measurement that the PAM team is heavily involved in is modeling, econometric modeling and causal inference modeling. So this is when we take that measurement one step further than that descriptive element and build some sort of model to understand what the incremental value is. And I'll touch a little bit on what the incrementality means as we go through here. So skip on to the next slide, please, Rob. So where does PAM sit in the customer analytics team? We sit on the right-hand side right at the end. So there's quite a lot of stuff that comes through this chain from commercial insights, working with our stakeholders to understand opportunities. They pass these insights to the data science team, who create some sort of predictive model, propensity model. This generates customer lists for targeting. These customer lists are then passed to PEGA, our decisioning engine, and these customers are targeted through all of our typically digital marketing channels. And it's up to the performance and measurement team, the PAM team, to understand what is working across all of this range of activities that are going on, so that we can do more of the stuff that works and pull back on the stuff that isn't working. And from the performance and measurement team, you can see the arrow going down. So we provide performance data and insights, which feed back into the front of the analytics chain, leading to data-driven prioritization and delivery. So anything that's coming through the analytics chain takes into account the performance feedback that we provide on previous activities. So everything is data-driven. On to the next slide, please, Rob. So I would say the most important concept for performance analytics and measurement is this idea of incrementality. So if we think about some outcome, whether it's sales, the total outcome can be split into two components. It's baseline plus the incremental. And incremental is what we get on top. So this is what we generate over and above what would have happened anyway. And this is really what the PAM team is trying to measure across all of our activities. So what is, if we think about the analytics chain, so what is the incremental value of a propensity model? What is the incremental value of a marketing campaign? What is the incremental value of some sort of decisioning strategy on PEGA? What is that providing over and above what we would just get anyway? So that's how we understand what we need to scale and what we need to stop. And I'm sure we can all do the mental computation required to understand that if total income or total outcome is equal to baseline plus incremental, then incremental is equal to total outcome minus baseline. And a lot of the techniques that we use are really around modeling what that baseline is. So the best example of this is a control group. So the graph on the right-hand side here shows we have some sort of test group and a control group. And the difference between those two groups is the incremental lift, where the control group is our best guess, our best estimate of that baseline, what would have happened anyway. And anything that happens above that is the incremental value. So on to the next slide, please, Rob. And one of the interesting things about the PAM team, or one of what I would say is the most interesting aspect of working in the PAM team, is the huge range of problems, challenges, and measurements that we are involved in. A real wide range of problems that lead to different types of modeling, different problems to solve. And one of the key aspects of our role is deciding what is the right tool for the right problem that answers the right question. And these can range, there's a wide range of tools and techniques that we use. So if we can randomize, we might use something like an A/B test or a holdout group. These are really the gold standard. But randomization at the scale that sometimes that we need can be costly, both from a business perspective, but also from a resource perspective. It can take a long time to set up. And whenever we are executing a marketing campaign, for example, if we expect that to generate revenue, the the more customers that we hold out from receiving that communication, the more that control group is going to cost, for example. Geotesting is another example of measurement that we do. This is quite becoming quite topical in recent days with the ever increasing restrictions on customer data and data privacy. So being able to create some sort of randomization at the geo level so that we don't have to manipulate customer data is becoming quite a very useful and convenient way in order to do these types of measurements. And what is a common type of measurement that we would do is econometrics. So this is when we have low granularity or data limitations. So if we're doing a measurement at, say, a market, a channel level, so we're not looking at customer level data, or we have some sort of limitation where we can't set up a geotest, we can't set up a randomization or a control group, we will use econometrics, which are essentially just statistical models. On to the next slide, please, Rob. So the first example of these measurements in action, so these are both real measurements that we carried out in customer analytics and in the PAM team. First one is around understanding the impact of PEGA. So the problem statement arose that we wanted to understand what value is PEGA driving and how can we generate confidence and credibility in scaling PEGA across our digital channels. When we first carried out this piece of analysis, the PEGA system was live on the app channel only, and we were trying to understand and build credibility for scaling the PEGA system across more of our digital channels. PEGA had been running for a number of years already by the time we came to do this measurement, so there was no convenient or easy way to set up a control group. So we had to think of something beyond a kind of experimental design and start using more statistical modeling, econometric type techniques. And what was a really nice fit for this type of measurement was something that we call synthetic control method. And this particular measurement technique creates that kind of estimate of the baseline by looking at all of what are called the donor channels. So these are the digital channel that we were measuring is the app channel. So we took a weighted combination of all the non-app channels such that weighted combination matches the pre-treatment period. So before PEGA was launched, and that generates a credible counterfactual. And then the difference between the actuals and that counterfactual is how we measure the incremental lift of PEGA. This proved to be a very successful piece of analysis. The synthetic control method fitted very well for this particular problem and generated a very credible counterfactual, which gave us the confidence that the impact of PEGA was substantial, and it was we generated a lot of confidence that we should scale PEGA across our digital channels. On to the next slide, please, Rob. And one good example of the benefit of that scaling of PEGA across digital channels is on the fixed rate roller campaign analysis. So this is a piece of analysis that was carried out by none other than our own Robert Sullivan. And the problem here was understanding the effect of a outbound dialer campaign on our fixed rate roller mortgage product. The question was, should we continue to run this campaign? Should we continue allocating the resource required to run this campaign? This was an interesting application of a model called instrumental variables. Now, I'm not going to go into the math or the details of instrumental variables. I would encourage you to read in your own time, as it's quite an interesting method of measurement. But it's a really powerful technique in order to get a clean estimate of the effect of something in the presence of selection bias. And the data set that we were using for this measurement had clear indications of selection bias. And we did quite a lot of thinking around what is the best way to construct an instrumental variable. And we came up with a very good identification strategy that allowed us to measure the incrementality of the campaign. And that eliminated a lot of that selection bias. And we were able to see that there was a massive difference between the naive estimate and the actual real estimate that strips away that selection bias. The outcome of this measurement led to us identifying a commercial opportunity within the data. This commercial opportunity was a segment of customers who we thought weren't being targeted very well by the outbound dialer campaign. There was an opportunity there to take this particular customer journey and rebuild it in the PEGA decisioning engine, which now is live across multiple channels, so that we can build a customer journey that brings in that kind of multiple channel approach and allows us to measure things in a much more comprehensive way as well. On to the next slide, please, Rob. And that's it for the customer analytics team. I think for this one, we were to give our projections on where we think the future trends are for our respective areas. So I'll invite my fellow speakers to provide their thoughts. But in terms of where I see marketing measurement going in the next few years, I think a lot of the momentum is around this idea of triangulation. So this is, if we think the three main pillars of marketing measurement are econometrics/market mix modeling, incrementality testing, so things like A/B testing, geo holdout testing, and multi-touch attribution. So this is modeling the effectiveness of different customer touch points across a digital journey. Triangulation is the combination of all of these different modeling techniques into a decisioning system, so that the continuity and the consistency of the results across these different ways of method provide that confidence through triangulation. That's where a lot of the big brands and a lot of the industry momentum is heading in terms of marketing measurement. Another aspect is the increasing the use of Bayesian methods, so being able to input priors and previous results into measurement in order to constrain the model's calibration to provide more sensible and more accurate estimates is another area where marketing measurement is heading. Any thoughts on future trends from the other speakers?
Yeah, I can talk about the future of decision, what we're working on at the moment. There's obviously all this automation, generative AI embedded in all of these platforms now, but there's also the generative AI use for all kinds of results that are not necessarily as complicated or as complex as you described, Aaron, but we do have our metrics as well in terms of how the platform is doing and all kinds of metrics that we are looking at just to make sure that we're on track. So I think that is what is coming into decisioning now, and that will allow us to automate the way from insight to message in front of our customers. I think at the moment there's quite a long time from idea to value, so that can become quicker through automation and through starting utilizing some of these tools that are now available or embedding them in our platform. So that's mostly where we're looking at the moment.
Great. At 1:50, I think we'll say thank you, and we'll open the floor to any comments or questions.